So hello again. Tonight we're going to talk about observing an astronomical event that's coming up not immediately, and we don't have a precise date for it, but sometime in the next, let's say, better part of a year to maybe next year or so. This week, Monday, there will be the partial solar eclipse for Fort Lauderdale, and we'll have a telescope at MODS, at the Museum of Discovery and Science, for people to gaze at that. But I was looking for other astronomical events that people could look at. And what I found out was there is a star in a constellation that is expected to go nova, not supernova, just regular old garden variety nova. And that's what we're going to talk about. So this is a periodically recurring stellar nova, estimated to occur in 2024, sometime between April and September. At maximum brightness, it'll be bright enough to see naked eye at night, not in the daytime, for a handful of days, maybe 3 days or so. So given that it occurs only every 80 years or so, it's actually more of a once in a lifetime occurrence than observing Comet Halley, which is about 78 years. So if you're willing to make the effort to look at a partial solar eclipse from your home location, then observe, or you're willing to, if you're young enough to wait for observing Comet Halley, then maybe observing a stellar nova that's reoccurring might be something you'd want to consider. So what is T Coronae Borealis? T Coronae Borealis, or TCRB, is a binary star system in the constellation Corona Borealis, which is Northern Crown. It's about 2,695 light years from Earth. It's in the Milky Way galaxy. In the sky, it's in the east-northeast, but remember the Earth rotates, so it's near polar rotation, so it's going to move around the sky. It's often low in the sky, so it's below 45 degrees in the 20 to 45 degree range. The star itself is typically so dim as not to be naked eye visible. Some people say unaided eye. I prefer the old phrase naked eye. It's a gravitationally interacting binary system. It's not a visual binary. In other words, the two stars aren't just merely separated in three-dimensional space. They're actually working around one another. One of the stars is a class M3 red giant, and the other one is a very small white dwarf. White dwarfs are classified as D. The orbit is almost circular, which means whichever one is currently the more massive, the other star will orbit it. So if the white dwarf has more mass concentrated and the red giant is larger and puffier and weighs less, then it's going to be orbiting the white dwarf. But it's orbiting it close enough that the orbit is about every 288 Earth days. The orbit is not flat, so it's not in the plane of our solar system. It's tilted about 67 degrees from Earth's perspective. So when one of the stars goes behind the other, it'll cause it to get brighter or dimmer. So we have to make sure that we're not being confused by that 288-day periodicity of brightening and dimming. Orbital separation is a fraction of a light year, 8.4 times 10 to the minus 6 light years, or about 50 million miles or 80 million kilometers. So as space goes, half an AU is the distance from the Earth to the sun. So it'd be like, where Venus is compared to the Earth. They're close enough together that we would see them, even if we had like an amateur telescope, we would see them as kind of a dim reddish single star, because the red would be mixed with the white dwarf and we put it all together and be a very faded red star. But it's actually two stars. So where is it in the sky? This is a section of a sky chart from Starry Night Probe. And you can see Polaris off to the left. And if you make a measurement from Polaris 2 stars out into the handle towards the cup of the Big Dipper, take that distance, and then you multiply along that line 6 times. You will get a spot in the sky that is directly below T Coronae Borealis, in the constellation of Corona Borealis. And from the spot that you're at up to Alphecca or Gemma, that star in Corona Borealis, which is the brightest one, about half that distance is where you'll find TCRB. But since it's so dim, you won't be able to see it. So you'll be able to see the spot that's below it and the star that's above it, and then blackness. But that's where it is in the sky. And remember, as the sky rotates around Polaris, as the Earth turns, it's not always going to be exactly the same spot of the sky. So you can use your stellarium or your sky chart or whatever to locate where Corona Borealis is. And if you find a bright star in that constellation, just go the opposite direction, and in the same constellation, you'll see where it's located, but not yet visible. Now, when it goes nova, it'll be visible in the night sky, naked eye, for a couple of days, and then it'll go back to being invisible again. If you're lucky enough to have an automated telescope for go-to and tracking, and you want to tell it to go to this thing, well, your hand paddle or your software may not know what a T Coronae Borealis is, but it's that particular pairing of stars has a number of catalog entries because it could go nova. So lots of catalogs. And we'll go through the individual ones, but you can see there Hipparcos and HR and Henry Draper and Smithsonian and Giant 2MASS and lots of catalog entries. But what is going on here? If you remember last week, we talked about vampires and zombies. This is the vampire stage. The white dwarf has enough gravity to pull on the loosely gravitationally held matter that's coming off of the bloating of the red giant star. So as it sucks this hydrogen, helium off of the red giant, as it puffs it out, it creates an accretion disk, basically a sealing covering over the white dwarf. And that causes increased pressure. And ultimately what happens is that helium and hydrogen is so tightly contained, and the amount of energy it's containing, it starts to fuse. So you get nuclear fusion, and the accretion disk material detonates, and that's the nova. It's not big enough detonation to actually blow the two stars apart. That would be like a type 1a supernova. It's just a regularly occurring nova. So long as the detonation of the accretion disk of the white dwarf doesn't destroy either of the two stars, the buildup and the detonation would be expected to occur periodically. So gather from the red giant, make an accretion disk, oop, got above the threshold, detonate, okay, extra pressure relieved, start doing it again. So if the first time this ever occurred, it was not sufficiently energetic to destroy either star, to make it stop the cycling, then this will occur again and again. But remember, it's not a zero sum. The red giant is puffing off material that gets beyond where the white dwarf can suck it in. So that's lost to the system. And when the nova occurs, it blows out some of that material, and some of the red giant also gets blown away with it. Not enough to destroy it, but just it loses some mass, some of the hydrogen and helium that it was using for the nuclear detonation. So the system loses material, and if you do this cycling enough times, then eventually you'll have drawn off so much from the red giant that you won't be able to detonate again. It'll take just way too long. Or you'll have drawn so much off of the red giant that the red giant now also wants to become a white dwarf, and it collapses down. But there's no indication with TCRB that it's done this often enough that it's going to stop doing it. But there are indications that the system, total energy, total material is changing. So I went back and did the study on how often has this occurred? When did it first? Well, we believe the first occurrence of it occurred in 1217. And that's just a maybe because it's kind of sketchy evidence. But in 1787, that was 570 years later, they had somebody made and jotted down that like this star got bright and then it dimmed out again. And it was in that part of the sky. So a recorded observation. But all the times every, 80 or so years before that, through that 570 years, people may not have noticed because it was, from 1217 to 1787, and there was some not great times for the human species in that period. So maybe people didn't look up or didn't write it down. But by the time we got to 1866, people were recording stuff, not only recording that it occurred, but recorded how bright it was. So it went from 1787 to 1866, roughly about 80 years. Then they were thinking it was going to occur roughly 80 years later. And sure enough, in 1946, now either they were more accurate as to the brightness or it wasn't as bright. Remember, the system gets dimmer as it loses energy. So it went from maybe a magnitude 2.5 to more likely a magnitude 3. Now, is this just improved accuracy of observation, or did the system lose enough energy to not get as bright when the nova occurred? I'm going to assume it's the latter and say the system still cycles, but maybe not as quickly or as energetically as it has in the past. So think about the one in 1217. That one was probably very visible at night, but nobody noticed. So in 2024, 78 years later from 1946, they saw it start to dim. Now, remember, it's a binary. So the collective brightness is the brightness of the white dwarf that's getting shielded by the accretion disk, and it's the combined with that brightness of the red giant that is getting smaller with every recurrence. And it's got a lot of material sucked off of it to form that accretion disk. So the total system dims out just before it detonates. And they saw that back in 1946, that a year before it detonated, they saw the whole system, that, two stars looking like one, got a little dimmer. So it's going to happen again. In mathematics, there's a process called induction, where if something happens once, you've only got one observation. If something happens twice, you've got two observations. Maybe something's going to connect the dots, so to speak. If you've got three observations, now you can essentially connect the dots and see a progression. I'm one of those connect the dots type. And I think that instead of it occurring in 2024, if the progression holds true, I think it's going to be more like 2027. But doesn't hurt to look for it, because it happens when it happens. And I also think it'll be a little bit dimmer than last time. So maybe magnitude 3.5 instead of magnitude 3. But, what do I know? I'm just some amateur out there. So everybody wants to know, okay, that's interesting. So when is it going to be visible? Can I book a date on my calendar and, set my stopwatch? Like, no. They've seen that it dims before it goes off. It was originally predicted for July 3rd, 2025. Hey, a 4th of July star. But now it's targeted for April to September of 2024 because they saw it dim. The dimming may be significant to the accretion disk getting close to the edge, or it may be that the red giant just was blobby and it sucked in a big blob of plasma from the star, and that caused the system to get briefly a little dimmer. So this is not an eclipse. This is not about orbital positions in shadows and things like that. This is about a nuclear detonation fueled by a variable amount of material going from one star, creating an accretion disk on the other. And, I can't tell you an exact date. I can tell you a ballpark. It's going to happen in the next better part of a year to a couple of years. No exact date. But how bright will it be? Well, I was talking about magnitudes. The last time was magnitude 3. Prior to that, it was magnitude 2.5. Wait a minute, the numbers are getting smaller. Does that mean smaller is brighter? Yes. So just for reference purposes, I put a list together. The sun is about magnitude negative 26. The moon is negative 12. The bright star Sirius was once thought to be like 1.0, a nice round number. Pick the brightest star in the northern hemisphere as your 1.0. It's actually minus 1.46. Vega was also supposed to be a 1.0. Turns out it's a little brighter than that, so 0.026. Polaris, which is actually a double star, is 1.98. The naked eye limit is about 6. So if you see stars listed as 6 or a higher number, you're going to need a telescope of some kind. And if it's greater than 15, you're going to need a telescope on top of a mountaintop or the Hubble Space Telescope in low Earth orbit. And if it's any dimmer, any higher a number than that, you're going to need a deep space telescope like the James Webb Space Telescope or Gaia out at L2. But as historically, this particular nova went from about 2.5 to about 3. I suspect it's going to go to maybe 3.5. Now there's another nova that's going to happen, very similar, Betelgeuse, but that's the detonation of the red star itself. Betelgeuse is a supermassive red star. That one they suspect, because it's only about 500 light years away from Earth, that one might be visible in daytime, and it would be visible for weeks. So I'm just planning the easy one, going for the low-hanging fruit here. T Coronae Borealis. Betelgeuse, it's like, Betelgeuse is like fusion. Fusion is every 10 years, we're going to have it 10 years from now. Betelgeuse is like every 10 years, this star is going to detonate 10 years from now. Well, this sounds very interesting. Is it going to be a public observing event? Planning for this partial eclipse on Monday was a lot of planning, a lot of coordination, getting all the ducks in a row, getting the media lined up, social media, posting things through marketing channels. But you had an end date. The end date was not going to change. The time range, like 1 to 4 p.m., that was not going to change. So it's pretty easy to plan for. Now let's go back to that same process and say, I want to plan for an event that I don't know the exact date, and it's only going to be visible at night for a couple of days around its maximum brightness, but I can't tell you what that date's going to be. But it's going to be bright enough that if you turn some street lights off, you could easily see this thing from a city, from urban areas. So I was thinking a parking garage that has an open deck on the top, so exposed to the sky, with some of the deck lights turned off. That might be a very good site to do it, because you can do it from an urban area. You don't need to go out to an observatory and maybe a rural area. You don't need to go out in the Everglades to see this thing. Parking costs for a couple of hours at a parking garage is probably a reasonable entrance fee for such an event. If you could find a flat rate garage where they didn't charge you by the hour, that would be even better. It's a large space, rooftop, flat, open garage. It's easy parking for the astronomers bringing telescopes. They can pull right up to where the telescope is going to be set up, set it up, tear it down, drive away. It's a large enough roof area that you could set up a large number of telescopes. You could put easily 50 telescopes up there and still have plenty of rooftop parking for 100 or so people to be there looking at it. And the garage being multiple decks, lots of parking space. But you'll come there to observe it for that couple of days window. And if the weather doesn't hold up, sorry, there's no rain checks. It's not going to wait for you. So it's not possible to specify a specific observing session event date and time. And it's going to be for, maybe a 2-hour or 3-hour observing session for 1 or 2 nights. So how would you coordinate this thing? Well, sometime between April and September for about 3 days. Start planning now because it's already April. You're going to have a conversation with the local community or organization about the parking structure and the variable nature of the event. Talk to some amateur astronomers, because if they're available now, they might not be available in, I don't know, August, when it might finally occur. So you have to have not only astronomers, but you have to have backups in case that particular window, they're not available. They're out of town on vacation, or they come down with the flu or whatever. They've got, work to do in their day job. The staffing for it, if you have event staffing by the city or a county or an organization like a museum, planning what the staffing is going to be like for an unknown date in the future, it's on demand. It's like, okay, tonight we're going to have the event. Who's on shift tonight? That kind of thing. I'd say announce the range of possible months or days. Go ahead and do that through your normal PR channels. If it turns out that you have some other committed event that happens to unluckily fall on that date, slip it out by 1 day. It's probably not going to be a big deal. Use social media for the exact notifications so that, if people follow that event and say they'd like to go to that event, and then the event doesn't happen for 4 or 5 months, they're still kind of on the hook to get the notification for, hey, it just started. We're going to be doing it tomorrow night and the next night. So, yeah. And do invite amateur astronomy organizations to participate because you never know who's going to be available. And invite the general public. It'll be an easy enough target, a bright enough star that even, somebody who has a lesser capable telescope that they have to manually point will be able to see it. Somebody with a Newtonian reflector on a Dob mount, you can see it. This I thought was interesting. I followed this years ago. The city of Flagstaff, Arizona recognized that astronomical observing by the general public and amateur astronomers is actually a source of recurring tourism revenue. So Flagstaff, when you say Flagstaff, people go, oh, that's where the observatory is that you can go to, and they're open and you can, and so it's good that lots of other stuff in Flagstaff area, or an hour or two drive around, and it's considered an ecotourism revenue source. Well, observing a nova from whatever city chooses to do it would be a once in a lifetime event. So you can promote it as such. It's not a partial solar eclipse where, yeah, we'd really like to be on the path of totality, but our city isn't located there. There's no path for your city to be located on to be lucky enough to see totality. And you don't need any special solar glasses to protect your eyes. It's just looking up. So if that particular star is visible from your latitude, in other words, you're not down in the southern hemisphere where you can't see the northern pole of rotation easily. And if you're lucky enough to not have weather obstructions from buildings and trees and shrubs and stuff, if you can see it from the top of an open deck rooftop garage and you don't have bad weather for the couple of nights that you're going to be looking at it, it's kind of it's going to happen. Promote it as a once in a lifetime ecotourism event. And therefore, don't just promote it through your normal channels, promote it through your normal tourism channels, through the hotel groups that are in your area, your county, your state, your city. Let them know it's going to be a happening thing because you've got a city or a county or a museum that's backing it, and they're already contracted in and committed to back it. If you plan on selling paraphernalia, you're going to have people buying T-shirts and such. Don't print the T-shirts right away. Don't go, it's going to happen sometime between April and September, because that's kind of a bogus thing to put on the T-shirt, because maybe it doesn't happen then. But when the nova occurs, and you talk to your local astronomy community, when the nova actually does occur, you need a rapid, expedited turnaround on producing your T-shirts, because then you can put a date on it. Then you can say, a T-shirt that says, I saw a nova of TCRB from Fort Lauderdale, did you? That would be a T-shirt you could print as soon as you know the nova occurred. And you could sell them at, hotel gift shops, museum gift shops, and you don't need to have a large inventory. You don't need to print thousands of them because you don't know how many people are going to show up and whether it's going to be a weather bust or not. So print a few hundred, sell them at a price that matches that, and you're good to go. You're golden. But I don't think you're going to be able to charge $600 a night for your hotel room that's normally $125, like they're doing for the solar eclipse, just because you're on the path of totality. So market accordingly. So in conclusion, a supernova is a far more energetic, brighter than a non-supernova. This is a non-supernova. It's not as predictable as an eclipse, probably a window, and it's a once-in-a-lifetime window. Currently, the window is April to September of 2024, but I'm thinking it's going to be a little farther out than that, but won't know until it actually occurs. It'll be maybe somewhere low in the east-northeastern sky. So if you've got a clear horizon or an elevated location like a parking garage top deck with some lights off, you can see it. It's currently at magnitude 12, because remember, it's normally 10, but it's dimmed it down to 12 as the accretion disk is like taking more in. It's going to brighten maybe magnitude 3.5, maybe as bright as magnitude 2. So definitely naked eye visible without a telescope at night. And then after a few days, it'll drop back down to about magnitude 6. And then beyond that, you won't be able to see it again without a telescope. And then, if people are coming late to the game, You'll have to go to an observatory to see it. And then when it gets even dimmer, then you'll only see it with the James Webb Space Telescope or Gaia. Use social media for your announcements of when the event's actually going to occur. Do promote it through your normal hospitality channels as an ecotourism event. And will you see this once in a lifetime event? And then I've got a few links. Comments? Questions?
Yeah, well done.
I thought it was
That's
organizations are often looking for things they can do with the general public. And if it kind of is close enough to follow on the heels of an eclipse, hoping for a clear sky, then you're going to get a certain number of people in your community that are interested in such things. You need to find a way to promote it appropriately because you don't know exactly when it's going to occur. But I think it's the kind of thing that when it happens, people can look in the sky right now and not see something. And then when it happens, they can look in the sky and see something. And then a couple of days later, it's gone. So it makes space dynamic for them, not just like an eclipse of the sun or eclipse of the moon or planets lining up in the sky, all of which are things that people like to go see. This is really, since it occurs about roughly every 80 years, it really is a once in a lifetime astronomical event.
I don't think this is going to make the news as much, but it really did tie in very well to
it's actually already in the news, and there are YouTube videos, people talking it up. But I don't think you're going to find any city, county, state, or museum or observatory committing to it because they don't have an exact date. And they only engage the business mechanism when they have an exact date. You know, put a stake in the ground, save the date, that kind of stuff. Well, this is save the window.
It really tied in very well to the zombie presentation.
That's why I had to do it. Is eclipse coming up? Just talked about vampires and zombies, and now we've got a vampire event going on that will detonate and create a once in a lifetime naked eye visual event that happens at night, and you don't have to go out to the Everglades. You don't have to drive off to some rural observatory, but you got to get somebody to do something.
Pretty cool.
Yeah. Okay. Any comments or questions? If not, then I'll stop recording. Hearing nothing.